and welcome to Storage Developer Conference by SNIA. I'd like to welcome you to my session, which is Practical Swordfish Implementations. My name is Chris Lionetti, and we're going to go over some interesting developments in Swordfish. Let's go ahead and jump right into it. So, the first thing to consider when deploying Swordfish, what is Swordfish? Swordfish is a new management model. Well, it's been out for a few years now. But it's an approach to doing storage management that builds on the already highly successful Redfish technology made by DMTF. So the Data Management Task Force has come up with a standard called Redfish, which uses modern technology of RESTful interface over HTTPS using JSON. It's very, very lightweight. This is the kind of thing that sits on the BMC, the baseboard management control, of individual servers. You'll find that all the server manufacturers, the HPs, the Dells, the Supermicro, Cisco, IBM, they all have support for Redfish in their products built in. So servers have already adopted this for all their baseboard management. What's important, though, is that Swordfish is an API that builds on that Redfish success. We've taken and made an extension to Redfish that gives us the ability to support more complex options, such as pools and classes of service. So we're going to go into what this does. And I'd like to point out that when we expanded Swordfish, when we expanded storage in the Redfish model to create Swordfish, we went ahead and went in with the idea of being able to model from the smallest SAN devices all the way to the very, very largest. But it had to also fit in and meld beautifully with DAS drives, direct attached storage, built into the server itself. So you're going to see there's a lot of flexibility here. It's also flexible enough to handle things like software-defined storage or handle NVMe. So we're going to go into that as well. So the hierarchy of how this works is when you connect to your Redfish client, you're going to connect to your Redfish client. You're going to find a whole bunch of different folders like systems, storage, chassis, managers. And these things, once you've gone to sessions and grabbed a token and logged into the device, and what you do is you simply add your token to every request after that, you're going to be able to query everything about that device. But more importantly, you're also going to be able to use JSON to create new posts and puts instead of just doing gets. So instead of just doing a read of the device, you're actually going to be able to post and say, I want to create a new pool or I want to create a new volume. So this is a complete storage management model built on that RESTful API. I should note there is a number of ways that you can look at this. In fact, I recommend the one I recommend for new people first is the mockup site. And I'll go into what that is as well. And there's a lot of tools out there to make this easy for you. Something we've just released recently that I want to make sure we told you about was the Swordfish Conformance Testing Program. So when you create your own Swordfish implementation, you can now actually submit that for testing to see where you're matching with the standard and where you're not. Now, we've also written a few other tools. For instance, there's a Redfish Swordfish emulator out there. You could download and run an emulator of Redfish or an emulator of Swordfish. We have a Swordfish mockup website. We also have a Redfish mockup creator. I've also written a PowerShell provider framework, as well as a PowerShell Toolkit, so you can query Redfish right from the command line of any machine without the need to actually make REST calls directly. Which, of course, if you needed to, you could do directly from Chrome or Firefox simply by putting the address in, and it will automatically read the JSON that comes back. But let's go ahead and take a look. So what the tools look like is, on Swordfish and Redfish, there's two halves to the equation. There's the providers, and then there's the consumers. The consumers are somebody who wants to write storage management. I want to write an application that talks to storage vendor A, B, or C, and can create volumes, create initiator groups, things like that. Create snapshots, delete snapshots. That's where my storage management lives. And for that, Swordfish is the perfect way to do it. You can actually talk to your servers. You can talk to your storage. You can find out and query everything about the real world. That's if you're a storage management app provider. Additionally, on the Swordfish provider side, there's a number of things you can look at. You could look at swordfishmockups.com, which is a site built on JavaScript that will automatically create or automatically bring up samples of what simple and more complex Swordfish implementations may look like. So those mockups that are built on swordfishmockups.com kind of give you, they're not exhaustive. They don't give you everything the model supports, but they do give you a really good idea of what a common implementation is going to look like. So they're very, very helpful. I should also note that I've written a Swordfish provider in PowerShell as a sample just to show how easy it is to do. You can actually take your API model and map it directly out, or you can simply take the emulator that's out there and modify it directly as well. So there is a emulator out there today written in Python. So if you'd rather work with Python, if you'd rather work with JavaScript, if you'd rather work with PowerShell, there's a number of ways to do this. And again, these are all beginner languages. You could use whatever language you want. There's even stuff in there for Go. But I should note that the Swordfish emulator is out there now. The Redfish emulator, it builds on the Redfish emulator. To install the Swordfish emulator, you're going to download Redfish emulator first and then put the Swordfish emulator on top of it. I should also note that the Swordfish provider, your storage device will eventually be its own Swordfish provider. Think of it just like a server would have, an HP server might have ILO, a Dell server might have iDRAC. These different servers have their own baseboard management control. Think of that as baseboard management control for your storage device. And it can do everything that you can do by logging in to your server, to your storage management software. So the idea is that you can put a lot of that knowledge, a lot of that API control directly into that provider. And by doing that, you can make yourself accessible by a number of storage management platforms. Now, on the client side, again, let's flip back over to the client side. I've written a little command line Swordfish Redfish Toolkit, and it can be used to query any Swordfish target out there. You can say, get me a list of drives, get me a list of volumes, get me all my pools. But I've just recently expanded that, and now it can be used to query any server in the market as well. Once you log into the server, you can say, tell me how many processors I have, tell me how much RAM I have. And then another client is the SNIA CTP. SNIA CTP uses Swordfish to actually test Swordfish compliance, because the idea is it makes a Swordfish call to your provider, and then your provider returns back the JSON to it, and it checks the JSON against a normative model to make sure it's proper. So the CTP, not only can it get you certified, but it's actually using the protocol itself to do the certification. So there's a lot of tools out there now to really help customers out who either want to consume Swordfish from a client side or from a provider side. Now, there's the Powershell Toolkit that I talked about. It was actually a little open source project we started between HP and Pure Storage, and it was designed where it could run in PowerShell on Windows, Linux, or Mac, but it can query a Redfish target, a Swordfish target, or a Swordfish Redfish emulator. It doesn't care. It doesn't even know it's talking to one or the other. So it'll just talk to those devices and gather all the information you want. The nice thing is, it will also let you, it brings back the REST API information and the JSON data as a raw object. So a PowerShell object and a JSON object are really the same thing. They actually convert back and forth to each other very readily. And I'll show you what that looks like. Here's when you download the Powershell Toolkit and you import the module, then you connect to your target, and this is the data that comes back. This is the actual PowerShell object that comes back. Now, don't get wonky with the @ symbol and the squiggly brackets. The @ symbol simply means it's a collection or a hash. And if it's a squiggly brackets, it's a hash. And if it's rounded brackets, it's a array. But I'll show you what that looks like in a minute here. So basically, when you do a PowerShell command, and you can say my vols equals get Swordfish volumes, that'll return, and each volume will be an array item. And you can literally take this variable, because remember, it's not returning text. It's returning the raw object. And that object is stored in that variable, which means I can take the fourth object of that collection, or I can say, go through all my objects and automatically select the object where it has the value of .name is equal to volume 5. So you can filter on all the different sub-items of the object. The nice thing is you don't have to write any of your own parsers for that. It's just automatically built into it from command line. You can also go into single variables. In fact, on this variable, you can see that links is a collection of many, many things. So if I wanted to open that up, I can simply choose that variable dot links, and it would give me all the items. In this case, I have a complex object called status, which actually has two items, which is status equal enabled and health equals okay. You can also take that variable and cast it right back into JSON format if you prefer to read the raw JSON that comes back. And this is what it looks like if I take that volume and push it back into a JSON format. And again, this is exactly what JSON looks like. This is what you would be used to with JSON. And you could take that and convert it right back into PowerShell. So the idea here is that we want to look at this data unmodified, untouched, unfiltered. This, by the way, is also exactly the same data you would get if you opened up a web browser to that exact location as well. So it's really easy to use the toolkit to verify you've got all your JSON properly. So if you need help on those commands, it's really simple because you just simply type, and everyone who uses PowerShell kind of knows this, you just simply type get command module name, and that gives you a list of the commands. And a few months ago, I had maybe 20 or 30 commands. Now I've got about 40 or 50, so I'm growing it very quickly. If you type get help and a individual command, it'll give you a list of the help for that command. These are the manual pages. And you can actually say, I want to see examples, I want to see the full help. You can also run the command in verbose mode, in which case it shows you the raw transactions going back and forth between that command and the device. So here's an example of what the get help looks like, because it'll give you the command name, it'll give you a synopsis, the syntax, the description, what the parameters are, what it expects to find in each parameter, some of the examples. So you can see that everything's self-documented and self-help. And by the way, these are all open source as well. If you go to the GitHub site, you could not only open these commands and see exactly how they operate, but all of these help files are built in the beginning of each command as MD. So Markdown language is used to write these help files. So it's very easy to keep them updated. And again, we're going to talk also about the fact that you're probably interested in implementing your own Swordfish implementation. So in that case, we're going to talk about how to do that. And to do that, it's pretty unlikely to come across a product out in the market that doesn't have its own REST API interface today. You're talking to your device through REST API from your own management app. The key is you want to be able to use the standard REST API app that Swordfish expects. In this case, you're going to need REST API documentation for your device. You're going to need a PowerShell, the PowerShell Toolkit you can download off GitHub right now that will expose, you're going to need a PowerShell Toolkit or some other tool that can expose that REST API directly, so you can see the raw JSON directly to your machine. A little bit of PowerShell knowledge. And then additionally, it doesn't hurt to have the Swordfish spec handy as well as Swordfish mockups. So the first thing you want to do, let's take something simple like volume. You're going to take the volume object from your device and expand the JSON. Take a look at it. And you're going to hold it side by side up to the volume object that you would see as an example from Swordfish mockups. Or you look in the Swordfish spec under the YAML or the XML spec and actually compare it there. And what you're looking for is you're looking for commonalities. Because some things you're going to have to change. You may report back in your REST API gigabytes or terabytes or megabytes or MB. But the point is that the Redfish tool, or the Redfish implementation expects to see it in a certain format. And all you want to do is be able to naturalize that format. So if you return it in gigabytes, but it wants gigabytes, then simply do the conversion and give them the proper number. But a lot of these fields are going to just simply transfer directly over. Additionally, there are other fields like thin provisioning, deduplication, compression. You're simply going to take the status that you currently have, plug it into the new status that Swordfish calls it. Here's an example. I have something called a cache policy. On my array, that cache policy is called normal, but I know from my own array documentation that normal cache policy on that type of array is adaptive read ahead. So if my cache policy returns back as normal, I want to return back adaptive read ahead, and if it doesn't return back as normal, I want to return back as off. So there's an example where I'm normalizing the language to meet the Swordfish spec. A lot of this is just normalizing the language. And let me show you what this maps over like. here's a command that's unique to my array. And here is what Swordfish Mockup looks like on just a regular storage array. So in this case, I notice there's something here called block size bytes. But it's all one word. It's block size bytes, and I got to get the case sensitive right. But on my array, it's block_size. So in that, all I have to do is make sure I change the normative name from block size to block size bytes. So a lot of these things are going to map over directly. Other things are not going to map at all, in which case the Swordfish spec doesn't support those, or it supports them in a different place. But a lot of this is really a mapping exercise to make sure that your API can be converted over to a Swordfish API. Once you've got this kind of mapping, also note that there are some things that are going to be hard-coded. Like, for instance, if your array only does triple parity RAID, then for RAID type, you would put triple parity RAID because there's no other option that's available, so you know that's a foregone conclusion. So my API might not return back RAID type because it's always guaranteed to be a certain thing. But again, for a Swordfish consumer, they wouldn't know that particular about my array, so Swordfish would explain it to them. Additionally, you can see here is where I'm creating an object that I want to return back. So what I do is basically I say, okay, let's do a volume object, and I fill in some literals. Everything in brown is a literal. For instance, manufacturer. Manufacturer, I'm hard coding in what that manufacturer is for this device. Provisioning policy is thin, compressed equals true. So some of these are going to be true no matter what, and I can hard code them. Other ones, I'm going to simply forward the same data in and maybe changing the format slightly. So you can see that for me, my state equals snapshot_state as opposed to being under a status. So I'm building these objects up. Once I've got those built up, it's very easy to create my own listener service as well. You can actually run, I built a simple one out of PowerShell just to show you how it's done, but you could just as easily do this in Python off of the emulator, or you can look at my code, but either one will work fine. The idea is that you can pull live information from a real array, go through your Python code, and have it serve out, and you can act as a proxy Swordfish server. So at that point, it looks a lot like the SNIA model used to look, where people commonly deployed proxies because you may not want to put it on the array, but it also could be put on the array as well. So as an example, if you look at my mockup creator, simply run the command called .listener, and it will connect to an array. And it's all open source, and you go in there and you actually would put your PowerShell toolkit in to query your devices, change the mapping over, and you now have your own Swordfish proxy, as it were. Again, this is just ideas to show you how easy it can be to do this mapping. This probably won't be the language you choose to do what the things you want to do. It's just to show you how easy it can be done in something as simple as that. So to serve Swordfish is really the goal here. We want your device to serve Swordfish, to be Swordfish compliant, but the only way to do that is actually to do the mapping operations, the mapping exercise, so that we can make sure it's conformant. Once we know it's conformant, you're going to find that people are going to use it in a lot of different ways that will amaze and make you very, very happy. So there's a lot of information out here. So the SNIA Swordfish site, you'll see that we have a number of resources. We have user's guide. We have a GitHub for all of our tools, and there is a lot of tools out there. There's white papers, YouTube presentations. There's the mockup site has got a number of different configurations, from simple configurations to large to small. There's a number of different places to go to get all this information. We tried to make it very, very easy. The key is, if you're a storage provider developing a Swordfish mockup of your own and submitting it to the Swordfish Technical Working Group can help to make sure that all your mapping is going properly. We think we've got it covered where we can scale from the smallest to the largest. The first argument I hear from people is the Swordfish protocol or the Swordfish mockup or design isn't built to scale in a certain way. We have yet to see an array or a device that can't be mapped to the Swordfish model. I know we all think we do individual neat widgets, and there's a lot of uniqueness between different vendors' models and different vendors' products. But at the end of the day, we all use pools, we all use volumes. You may have some special RAID group you use. That can all be incorporated into the Swordfish model. It's a very descriptive language, and it's very flexible in what it can do. We believe it can do software-defined storage as well, because you can have one Swordfish endpoint that actually handles 4 servers, and you can have a pool that spans all 4 servers. So because of that, we've actually gotten a lot of groups like Open Fabric Management Framework that have gotten very interested in this. Again, though, we think we've got a lot of stuff covered, but we're always looking for more feedback. Please join the Swordfish Technical Working Group and come to us with what you're looking to do. We can give you a lot of guidance on how to do this. Again, we've had people write Datadog implementations. We've had a Power BI implementation. There's a GoFish library out there and an Ember.js library out there. There's a lot of different people doing different things with this. Additionally, NVMe is being enabled over Swordfish as well. So there's a lot of different standards to go to. And again, SNIA.org/swordfish is probably the best one to go to. There's also a specification forum out there you can visit. We're doing a lot of really exciting work with Open Fabric Management Framework. NVMe Express it's a group that's entirely on its own, and they're working within spec, and they've expanded the spec greatly. And then we also work heavily with DMTF and the Redfish group to make sure that if something needs to happen at a baser level, because we share the same model. Swordfish and Redfish share the same model. I find that a lot of people who don't know where to start on Swordfish, I say, well, take a look at a server, see how they implement their processors, their memory, their Ethernet adapters, things like that. Then come back into the Swordfish model and start implementing all the other things that make it bigger and badder. So there's a lot of different ways to solve these problems. And I think that Swordfish is one of those lightweight storage management protocols that could really help out. We're looking for more people to do the conformance testing program as well. In fact, my company has released a product, HPE has released a product, that its native API is Swordfish, the MSA 2060. And we've been actually running it against the CTP, and it's been entirely helpful because the CTP tells us all the places where we're out of spec. And those reports have been hugely beneficial in for us to tighten up our implementation and make sure it matches the spec and it's usable by everyone. Hopefully this was a good session for you. Please leave feedback on these sessions. This way we know what sessions to bring you next year. So we bring back the presenters that we feel that you expressed a liking for. So again, my name is Chris Lionetti, and this has been Practical Swordfish. Thank you very much.